Okay. Right. It's raining here in UM, so you have to pardon me for some noise that comes from a natural cause. Okay, so no worries. Okay, so can you guys see the slide?
Yes, Prof.
Okay. Can you hear the sound of the rain?
No, I don't hear any sound of rain.
So it's like, we'll be talking with a background of the rain. Okay. All right. So this coaching session, second coaching session, is about visual thinking and storytelling. Okay. So you may ask, well, what's so special about storytelling? I can tell stories. Okay. Then how about visual thinking? I've been drawing since my early years. But how many of us still, still do, sketches to explain ideas in a visual form? We rarely do that. Maybe we don't have opportunity to do this, okay? And most of the time, we just send some graphs and we think that is visual. Visual thinking is different from presenting visual aids, okay? So that will be the core message that I'm going to press from time to time. So if you look at this, that's the first page of the slide. You see visual thinking actually consists of many components: visual analysis, visual storytelling, and visual communication. So in your GIS visual science competition, you will be doing all three. You will be doing some visual analysis of the satellite images, okay, or the Google Earth image, or anything alike. And then for a reason, there is a reason for doing this, okay? And then we need to bring that analysis to a public domain so that whatever we found from this analysis can be used to change something, okay, change a situation, right, or improve something. So in that sense, visual storytelling will be useful for better influence. And finally, it's always appealing to see things, okay? And you can see this is the basis for marketing these days, okay? The visual impact is very important. The first sight is very important. So how we capitalize visual effect in communication so that we communicate big issues, impactful solution, a finding, or change, a change effect in a better way. Okay, so this is what encompass the visual thinking and storytelling. Okay, and I'll actually break this talk into two parts. The first part is about GIS, the competition. I believe many of you probably have all sort of interpretation of this competition. Okay, I have teams from my own class who are mentored by someone else. They seems to be, having a very different point of view. Every different team seems to have a different point of view about what is the geographic information system. And the visual science is very much, it's not in the picture yet, but everybody is just trying to understand GIS, okay, using any software that you can find. But I think I have to stress the objective of this competition, okay? it has a mission. It's a goal-oriented competition. And you by the end of part 1, you'll know that why we are doing it in Faculty of Science, and we are encouraging almost all departments and institute in Faculty of Science to explore GIS, even though some of us in physics, in mathematics, in chemistry, probably never bothered to even to look at GIS before this, okay? Our friends from geology may be a bit lucky because this is part of the tools. And of course, people from the built environment, geography, environmental science are well versed in GIS. So for that reason, you know, one party may know GIS very well, or at least to the operational level. On the other hand, there could be teams or groups who have very interesting story to tell. They just need a platform to describe this. And for them, GIS may be something new, okay? But in between, we want to achieve a greater goal. So that is something that you guys need to understand when you build your story for this competition. And then a very important concept that is related to this competition is called the design thinking. Design thinking, if you do some quick search, you will find it is used in almost anything nowadays. Okay, in the design of electrical appliances, automobile, buildings, attire, even a narrative for a political speech. There is a concept of design thinking. So what is design thinking and why design thinking enters the picture? Okay, and then we will go to part 2, where we take the cue from design thinking, because visual thinking come about thanks to design thinking. As a designer, you have to visualize. As an architect, you should visualize what kind of building that you want to build. Okay, you want to design. So you have to visualize the outcome that fits the client's interests and the client's request. But at the same time, you must incorporate all these, the back and forth way of designing, or even, coming up with ideas. Okay. So design thinking will be something of a skill if you can master and implement in any of the projects that you guys are doing at the moment, including this competition. I think you can go far. Okay. And this is the design philosophy of the big tech companies like Apple, Dyson, Samsung, Toyota, and many companies. Okay, the design thinking concept. So with the motivation that comes from design thinking, one of the important component of design thinking is visual thinking. Then we'll go into part 2 and try to build up the visual science competitions, narrative. And then we will say that, let's draw, because it's a visual thinking. Let's draw the ideas. Okay, we don't write it down. Text is not enough. Okay, if you want to explain something in just text and equation, it's not enough. And equation itself is a visual. Okay, and finally, we look at the visual storytelling. All right. So that is basically our discussion for today's session. We'll try to give some time for you guys to digest and also to interact. So feel free during the break between part 1 and part 2. So we'll have some free time to have some Q&A. Okay. Okay. So what is this GIS visual science competition? All right, so let's just read a little bit. about this GIS science. Geographic information system augmented with live streaming, important, huh? Live streaming or archive data of social ecosystem, which means it could be a human activity. The data may come from human activity. It could also come from the ecosystem itself, like the sound of the rain, okay? The sound of the rain in my office is still bearable. It's pleasant. But if you sit somewhere, that sound of the rain will not, make it possible for us to have this discussion because it will be too noisy. Okay? So there could be data that comes from the environment, the ecosystem, the land, the water, the built environment, the air, the atmosphere, and also the fauna and flora that you see in this area, okay? And it creates a deep connection to a place or a phenomena, okay? So the sound of wind or the sound of traffic in the campus can be different from another university, okay? So the data, the environmental, geospatial, biophonic, geophonic, and anthrophonic, data that comes from all these different sources is tied down to the landscape. Okay, so we have a coordinate system. It has a data, and the data is what we actually call as augmented here. Okay, so you can have a live streaming video. Eventually, we would like to have sensors being buried everywhere, but you can also have archive data you collected as a sample of a phenomena that you would like to discuss, okay? And the connection to a place or a phenomena illustrates special relationship. This is important. We want to see spatial relationship and enable the use of the environment as an extension of learning space, okay? Sometimes I see the geology students they come out, they do experiment maybe at the slope. We see biological science students go out in the open and they do some field work, which means your space, extended space, is still a learning space. Now we ask, are we expanding this learning space or we are shrinking this learning space? This is what we probably would like to see from some of your contribution, okay? Whether our learning space is improving or our learning space is becoming very restrictive. It's not conducive for an open classroom learning. That is the kind of question you should ask, okay? So the competition is to create an up-to-date and accurate GIS map of the Faculty of Science complex, okay? This is quite important. In the past, in the last, coaching session, somebody asked, can we look at any other area in the campus? If we can do it for Faculty of Science, then we can offer this service to another faculty or another zone. We can promote this as a case study, as a pilot project. And this competition is basically sponsored by Faculty of Science. So therefore, we are committed to Faculty of Science to focus on the science complex. And in fact, you will see this science complex is indeed a very interesting formation, geologically and geographically. Okay, so this is again, we are tying up to the landscape, to the place. Okay, so many of you are from Faculty of Science. You may have friends coming from built environment and geography. It's just a matter of time. We can expand it to your own turf. Okay, if the idea can be propagated. So this is the idea. But we would like to focus on the visual science, and from there it can be propagated to other case study and zones. Okay, so now accurate GIS map of the Faculty of Science complex, highlighting 3 or more features. Okay, and for example, green patches. So if you see in this picture, you can see the green patches are the part of the Academy Pengajian Melayu Hill, and a bit of some shrubs in between the buildings, and then you have the Rimba Ilmu. Okay, and there are other parts of some greens. And Universiti Malaya also has been planting trees to create connectivity. Okay, so all this is part of a plan at the management of the universities. But how can we at the Faculty of Science and with our colleagues from other faculties can use this initiative on greening the campus as part of our learning space or learning models. So that is the idea of this competition also. It could cover green patches, water body, land use, man-made built environment, in addition to the natural environment or partially rewild space that is rewilding intentionally or unintentionally. And you can also focus on the social system, such as mobility. You can look at, the pathways where the students and the user actually commute, if they walk, and if they take their, any electric vehicles, the small, the electric motorbike, which pathway they use. If they use cars or bikes, which path they use. So the map could be useful for future, planning of the mobility in the campus, particularly in Faculty of Science. And there is another element that we actually highlighted, which is quite interesting, is the soundscape that I mentioned just now. The biological origin, we call biophonic. The geological origin, we call geophonic. And then a man-made sound called the anthrophonic. Okay, so different spatial points at the campus and the Faculty of Science has different soundscape. Okay, that changes over time. That's very interesting map. And then student leisure space. Are the centers or the cubes or the student hangout place properly designed? Does it have a very conducive circulation, healthy circulation of air and humidity? So you ask this question. All right, R&D hotspot. Our R&D hotspots are strategically positioned and planned for expansion. So all these are questions, are very serious questions that you guys can ask. Okay, so it is very important for you to identify the attributes or the features, because with a good selection of features, you can write a very good narrative of this GIS visual science story map. Okay, and the GIS map must be augmented with a story map. Okay, that advocates at least one sustainable development goal. So it has to be clear. If you talk about water body, then you'll be live on underwater, okay, or clean water. So at least you can identify, okay. Energy, you can talk about energy, whether the building have better ventilation, lighting, Then you can talk about energy consumption. Okay. So all these, if you take one area, you do it very thoroughly, it's just a matter of time, you can expand it to another area. Okay. So it can be done. All right. So your GIS map can have a static data or interactive data. Okay. So that depends on your competence and how well you mastered the GIS, so that you can enrich the digital map with a multimodal, image and signals. Okay. All right. So I assume that most of you have already formed your team, 4 to 6. Why we put 4 to 6? Because we want to make it, design thinking requires a lot of different expertise and point of view. So if you have people from the same department, from the same group, with the same way of thinking, it is very difficult for us to approach the problem in a rather, orthogonal, many different ways. Okay, so that's the reason why we said it's a team project, and at least 3 from science, because it is about science faculty. But then to take advantage of the GIS expertise from other faculty, we allow you to have more members, to complement the 3 from science. Okay. So some of you asked, what is the role of academic advisor? Okay. This is a project that empowers the students, primarily the students. Okay. But we would like this project also to be supported by lecturers so that they can bring their ideas into the project, or they can even ask the team to test the researchers, data, scientific data. So they can even use very, research-centric data that can be mapped. So if you have academic advisor, life will be very easy because your data will be at least is accessible from your own lab. Okay. So that is the reason why we said you appoint an academic advisor. We would like also this project to be continued in the future, so the academic advisor can keep repeating, their commitment, can be committed for the next sequel of this competition. All right, if they are enjoying this experience and also making their own research translated into some competition, and then we'll be empowering academics as well. So this is basically to get a win-win. We want students to actually come up with exciting ideas, and we want lecturers also to motivate the group to come up with exciting stories that meet the researchers, maybe researchers outreach, objectives. Okay, guys, so that is basically about the competition. Now, that's the biggest, the most important part is the winning digital submission will be used for promotion of visual science at the Faculty of Science. So now you know, okay, what is the purpose of this outcome? You want your contribution to win, and then the winning entries will be used by the faculty as part of the promotion of, the GIS information or GIS augmented information for the future student, for people to get to know our faculty. In fact, if you had difficulties in finding information, you do not want the future students to face the same scenario. So we want to put the data on a digital platform so that, like you go to, the faculty's foyer, you have a digital screen where you can actually access a digital metaverse of Faculty of Science eventually. Okay, So we are building this database. So as we go on and on, we will see more of the Faculty of Science go into a metaverse, and there will be a lot of things that we could do for the benefit of this faculty and the university. And someday you can come back and say that, you know, you have contributed towards the data, you know, data system, you know, the metaverse data system for Faculty of Science. So at least you leave a print, you leave a digital print, you know, for Faculty of Science. Okay. So we see the digital world is moving so fast. We can see the planets, we can see, you know, exploration on distant system, solar systems, you know, as if that we are actually manning the, you know, the spacecraft. Okay. Why? Because of this information system, the geographic or even space, you know, space data, you know, metaverse. Okay. So we should think big about this, you know, trying to transform the data and then enrich the data of Faculty of Science. Even the data itself is actually a manifestation of science. Okay, so that is basically the competition. Okay, so is there an expectation? The expectation is we want interesting ideas that captures important, impactful issues or interesting highlights of the faculty that the faculty are proud to put it up on their digital metaverse platform. So that is your target. It can be anything. Okay. So you must ask, you know, what exactly, you know, I should invent or I should design. Then this brings us to ask the question of, you know, the design thinking, you know. When people design something, they don't have, you know, they do not know exactly what people would like to have, but they may even paint a picture of what is good to have. Okay, then that idea sink into the consumer, and then the consumer will be a die-hard fan of that particular brand because the idea is very, very convincing. Okay, and that is by design. Okay, so that is basically about the competition. So now I give you a scenario. Okay, I give you a scenario. The picture that you see on your right part of the monitor or the screen is a simple, you know, visual capture of the pathetic state of a river system around Faculty of Science. Okay, so this is the picture taken by me. As I walk around, I take this picture. I want to build it up into a visual evidence, and then I overlay that on top of Google Earth, and you start to see. I'll give you a rundown on this. You look at this Sungai Pantai. Sungai Pantai is the one that runs, you know, between the physics department and the Faculty of Arts and Social Science. Okay, and it goes all the way to the lake. Okay, some of it goes into the lake, the other one joins straight to go into Sungai Pantai. Okay, so look at the situation. There is you know, the border fence that crashed into this I would say the drain, not river. It is in that drain, and if the water runs high, and it will create drag. So there will be a drag and a resistance to the flow. That is a scenario. Okay. Then you look at the you know, at the slope of the car park in front of opposite the parking lot in front of physics department and the food kiosk. Okay, food kiosk, the car park, you can see another, the drain fence has been broken. This is taken just a couple of months ago. So don't assume that this is taken 5 or 10 years ago. This was taken when this competition was designed. Okay, so pagar rosak near Sungai Pantai. This is Sungai actually, this is Sungai Pantai. All right, and then this is at the faculty science, the tri-junction, the T junction. Okay, and you can see lots of fences are actually, are buried in this, in this drain. A lot. Okay, so if you go near the library also, you will see one. Okay, near the library KDS crossing, you will see one. So it seems like this has been in this drain for a very long time. Okay, looking at the nature of this rust, some are recent, some has been there for so long. Okay, and you can also find a stream that flowing underneath the parking lot in front of ISM. It is a stream, but actually it looks like a sewage drain coming from the cafe. Okay, and you have a pond which was built for a purpose of landscaping, landscaping and to have some flood control. For Faculty of Science from KDK going down to our new science building or Makmal Science Baru. Okay, but look at the current state. Everywhere you see the situation does not reflect the sustainability that we preach. So I create a kind of tagline. This is what we need: environmental empathy. Okay, so now we ask, this is the scenario. Okay, this is a scenario. Now we ask, can we use GIS to bring up this issue to the forefront and then use some kind of powerful narrative that, that is based on visual scientific data? For example, the flow rate, the sedimentation, the debris, the obstruction, and the biodiversity of life in the water. To look at that as a kind of a statement, to build a narrative so that the data would actually tell, the real-time health of the water bodies in the Faculty of Science. This is what we call environmental empathy, that comes because we feel sorry for the environment. Who are we? The Faculty of Science, students, staff, visitor, whoever. If we don't bother about Faculty of Science, the state of Faculty of Science, who else will? And then we cannot go around saying that we are doing science that will solve the world's problem. So this is a kind of, a kind of contradiction that we are building as part of a storytelling. Okay, so I'm just picking up one example. There could be many, many examples. Okay, the state of building, maintenance, building paint, all, now with a lot of fungus. You have parasite growing on the buildings. Okay, parasitic plants, which eventually break the structure. We have a lot of underground, drainage blocked, a lot of things. Okay, so now you see, if we can highlight these using GIS map, build a very powerful story, and the data is actually living on the map, you have a very powerful story to bring to the attention. Okay. All right, so now we go to the big scale. Okay, just now was just a small part. This is the Faculty of Science. If I show you this picture, this is the faculty of science. Can you see the mouse moving? Can you guys see the mouse moving?
Yes. Yes, Prof.
Okay, that is the faculty of science. All right, look at this. This is the University of Malaya. This is University of Malaya. Okay. And we are the only, small patch of land that still maintains this green patch called the Rimba Ilmu. Okay. But even the Rimba Ilmu, one or the top hill has been, is now academy. And you know what happened? On the left-hand side, there is a landslide. On the south, towards physics, there's a landslide. On the other slope, there also potential for landslide. So this is how, failing to see the landscape and topography, to understand the stability of the structure, we actually just building, brewing a crisis to happen. Okay, so that is one. And the other area that you can see green is the golf course, the Kuala Lumpur golf course, which is not a public area. And some very, this is a Bukit Damansara site, which is a highly elite group. And you have the Bukit Gasing. So even from this picture, you are seeing that Universiti Malaya is sitting in an area which is basically a very sensitive green patch. Okay, so very sensitive green patch. And in that corner is the Faculty of Science. Okay, so we should be the custodian of the Rimba Ilmu Hill. Rimba Ilmu was part of the Faculty of Science research station. And it continues being even helmed by people from Faculty of Science. So we could do a lot for this region, but we start first with the vulnerability and the status mapping of this area called the science complex. Okay, because we have a very strategic position in this green hills. Okay, so it's a very important area. So hopefully, in 5 years, 10 years time, your GIS contribution would probably will revive this valley. Okay, we want that, and I hope you also would like to put that as your long foresight, so that when you come back in 10 years time, you can say, this is the area that I mapped, and I'm glad that it has been revived. Or you can say that this is the area that I mapped. I noticed that it was in a dire condition and somehow we failed to take notice. Either way, all right? So either way it can go. So your story can actually change the course. If your voice through your story is powerful, evidence-based, substantiated by technology that people use for mapping, I think nobody can deny the fact that it is a very important representation of an ecosystem in this area. Okay, and we scientists, we should try to fix something that is in a decline, or try to preserve something that is improving. Okay, so beyond just that small complex, you can ask 1 to 17 SDG goals, teams. You can ask whether there is a possibility for partnership between Faculty of Science, UMSDC, the Estate Office, and the research centers to revive maybe the quality of soil, the biodiversity of plants and animals, the air quality in the science complex, the mobility of science complex, the well-being, the psychospace of science complex. You can ask, I can tell you, you can ask more than one SDG teams. You can ask, okay? You can actually interweave more than one SDG. Why stick to one? Go more than one. Okay, bring that out through your SDG. So that explains why that competition actually go beyond competition. It is actually a wake-up call that we should rise to the occasion to uphold the SDG objective of the institution, of the country, and eventually as a planetary health. Okay, and if as a participants, you guys are conversant and you know about the ESG, the importance of ESG, environment, the society and governance, is a very important economic indicator. Okay, so any industry or sector you go in, you probably will see the ESG sitting in part of their fiscal interest. Okay, so it is good for us to start early, even though we are scientists. Many of us are scientists, but we should be able to rise up to the challenge to address these SDG issues. Okay, and that comes back to the UM's, often highlights their I would say their laurels in ranking for sustainability. But if you look at the river condition just now, we have hardly moved the muscle to even clean up the drain. Okay, the drain right in front of our faculty, we have not even come together to clean it up because we think it belongs to somebody else. Okay, so if the map can actually raise some awareness and action, be an advocate, advocate of some good cause, you guys are the heroes and the champions. Okay, so it goes beyond the green metric, whatever, low carbon city framework, living lab, and so on. Okay, so if you look at the map, you don't have many maps of Universiti Malaya. In fact, it's very hard to get a digital map. Okay, open source. It's very hard to get a digital map of Universiti Malaya, oldest university in the country, and it has evolved so much within the campus and surrounding the campus, but we don't have accessible data. Okay, so your GIS map could be one that Faculty of Science and you as a science student can be proud of, and the university can say that at least we have one detailed site or zone where we have really embraced the digital technology and digital data. Okay, so 1962, you see the small patch over there, and today the science complex is somewhere around here. Okay, 2021, and I marked the red shape here is what we call the science complex. Somehow we have colonized the hill under, on the slope of the APM. We may not have that territory, but I think for the sake of argument, we just put this as a territory. And if we build GIS with some building modeling software, we actually can have a digital representation of this faculty that eventually maybe you can send drones to do monitoring work. That's the idea. Okay, so we give a tag name for this zone as the K nexus. Okay, which means knowledge nexus of the science valley. So this is just a namesake. We just coined this word for the sake of this competition. Okay, so your GIS map will be providing the first pilot data for the connexus. Okay, that will probably take take off in 5 to 10 years. Okay, So now, coming back to this GIS competition, so what we say here is the GIS competition is expected to create place-based learning space, which means beyond your classroom into the open area, where you can put sensors, you can actually sit down and think. It's a living lab research stations. And thanks to the GIS competition, submission, the place probably will be revived so that it can be a sort of, a garden campus with sustainable, lively, ecosystem. Okay. So now if you walk from the Faculty of Science Central to the KDK, I don't think it's a pleasant walk. It looks like a barren land. For more than 10 years, the discontinued project remained as a discontinued landscape. Okay. So there was no effort to regreen or to restructure or something. So project like this probably will create empathy, increase in empathy. Hopefully there will be more large scale environmental concern beyond student taking environmental science. There will be appreciation of nature and some of the very well designed built environment. And we would actually have a bad taste about things that are not designed well. Okay. So this is very important part of the GIS, place-based education, extended, spatial space. Okay, competition. That is about the competition. So what is this competition? So how does this thing came about? It was inspired by the ArcGIS story map competition. Any of you check the website for this competition, ArcGIS story map competition? Any of you? Any of you guys go and check the ArcGIS story map?
No, not yet.
Okay. Your generation, if you want to eat the best, let's say best tom yum, what you'll do? What you'll do? Your generation.
Google search.
Huh?
Search in the internet.
Search. You do Google search, you look for opinion, and then you try to find what people said about it. So, in fact, that's your generation, man. That's the native instinct. Okay? Probably for many of us also. So before going to a place, they already found out everything about the place. So already have a pre-assumption, predetermined, ideas about things. So now I ask, this competition, we have been keep telling that this is based on story map, ArcGIS, or GIS. If you type GIS story, sure you will be, you hit this website. Okay. Then you know how people use this for telling stories. And look at that. Storytelling that resonates. Transform your digital storytelling with custom map. And if you look at the examples from the archive, if you move your cursor over the map, there will be an active data interaction. Okay, so that's what we call story map, and it is GIS. It's just that it came from a commercial software, ArcGIS. So if we can do it for any GIS map, and the fact that people are doing it because it is very powerful, narrative, influencing effect, okay, communicating effect, analysis effect. we should do it. Okay, so now after this coaching session, you should, if you have vague idea about what is this competition about, or what is the level of expectation, or how well we can do compared to what has been done by others in a distant land, then we should do this. Okay, so if you're really serious to really go forward and win the money, get your product or submission be used at the faculty or any other venues, I think you should check how people did it. And then you want to do it better. You want to have more powerful story. Okay, so go and check it out. The link is there. You just type ArcGIS story map. The competition for this year is over. I'm sure they will have a competition for the coming year. But this has been going on for over the years. But I assume probably only the geography and geology student may be aware of this. But thanks to GIS visual science, we can say that, you know, the whole Faculty of Science now probably know there is such a thing called ArcGIS story map. Okay. All right. So now we come to design thinking. Okay. So design thinking is a mindset. It's a shift from thinking about logical, sequential, serial into a parallel, interconnected ideas that can be drawn. So if you sketch your idea, you can draw on top, you can draw on the bottom, you can draw on the left, you can draw on the right, you can draw within, you can draw on the exterior, you can connect lines, you can network things, you can shade things, you can break up things. The syntax for graphics is powerful, okay, compared to the grammatical rules of language in verbal and in textual. So you need to know language, which we are so used to and become so rigidly tied to, which is the verbal and written, is only a small part of the communication skill. Okay, and we are now even writing simple sentences. And many of the sentences, thanks to ChatGPT, is actually pre-prepared. We only transfer from one source to another source. So we have lost the idea of mapping ideas. Okay, we have lost that skill of mapping ideas to see the big picture, then to have how things are connected. This is what we call design thinking. Okay. In a nutshell, but of course there are many technical definition for design thinking. Okay, so design thinking is just moving forward into a new way of thinking, but this new way is not new. This is how we thought when we were young. When we are born, we see the world in a visual sense, in a sensory way. Then only we learn the language. Then we learn to write, and then we narrowed our view about the world in a written and also spoken language. So the sensory systems have played minimal role in our interaction with the environment. So design thinking and visual thinking will bring this back. So that's the idea of visual thinking. But design thinking is to look at the system by focusing at the most essential, important component, that is the people. Okay? So what is design thinking? Design thinking is a nonlinear process, meaning that it's not just linearly, one lead to the other. It can suddenly change the way we understand systems, exponentially better. Okay? And you keep repeating, because you can go backward and then improve. So it is an iterative rather than one directional serial. Okay. and you want to understand the user. So in GIS competition, who's the user? Who's the user for GIS competition? Yes. Who is the user for GIS competition?
You mean I think it's the management of the faculty.
Okay. So we give a general idea, you see, the faculty. But then if your story is about student, then it will go into the student facility, student growth, student comfort. If it's about environment, then it will go to the, you know, the manager office, you know, the estate and manager office, who will look at it from a different way. So if you identify to whom you want to address this issue, you want to communicate this issue, then the way you build your story will be different. So you must understand who you want to actually address. If you take, for example, you know, the road traffic and mobility, okay? So students may be, you know, facing risk being knocked down by car because the way the roads are crisscrossing and coming from nowhere and suddenly at the sharp corners and so on, okay? So now you want to ask this question. We want to increase, you know, the percentage of students or user to walk in the campus. And then it is good, you know, it gives us, you know, some exercise, burn some calorie, and also you get the chance to actually see things around. But then who should, you know, should address that issue or take up your solution, okay? And then every step of the way, if you identify your user and you keep redefining, iteratively go forward and backward, okay? So you see, the idea must be empathized by, you know, by understanding what the user, the student side, and also the facility managers, okay? So you need to empathize, and then only you can define the problem well. And probably you have to redefine the problem. So this is what we call an iterative nonlinear process with a lot of feedback and loop. And this is not the way we solve our problem in our classroom. We are not solving problem in this way. Why? Because our problem is not complex enough. It may be hard problem, but it's not complex problem. Okay, so you can adopt a logical sequence of processes, you can reach the solution. But the kind of problem that design thinkers want to solve are problems that are real, where the solution is really necessary, but nobody knows how to do it because the approach is not correct. So they come up with innovative way of solving the problem iteratively. Solution 1.0, solution 1.5 or 2.0, solution 3.0, solution 4.0. That's why now you have iPhone 14. Why iPhone didn't start straight away become iPhone forever? Because of iterative improvement, understanding what the user wants. Challenge the assumption, the screen, touch screen, sensitivity, what kind of activity we do with touch screen. And then they build the capacity of touch screen. Security. So you see, the iterative process is the one that produced the iPhone 14 today over many. So same thing goes for your Microsoft Windows. All have iterative processes, okay? Because it's a complex process, the problem always change, okay? So the kind of project that you are embarking on falls under the same nature. So you cannot have a closed mindset. There is a linear way to solve it. Okay. So don't be afraid if you cannot solve it on the first iteration. You just go back and try to re-understand the problem, redefine the problem, talk to the user. Okay. For this competition, if you need the information, you should take initiative to engage the user or the facility owner. Okay. So we must be bold enough to go and find facts. You cannot be scared that we don't have a letter to, you must be bold enough to, because your intention is the user. You are empathizing the user who face some issues. So if you empathize, this is the time for you to change. And you approach, you head on with all the obstacles. Okay. So design thinking as a very early history. It started from the Bauhaus design in Germany, which produced a lot of devices, electronic devices that have a very nice, simple shape. Okay. Very nice, simple shape, not complicated shape, very squarish. Buildings also very simple, Bauhaus design. And the iPhone, Apple and iPhone is the student of Bauhaus design. So if today we talk about, some of the best companies, we have to thank the Bauhaus design in a design school for the philosophy of design thinking, putting what the user wants, aesthetic and functionality with minimal. Okay. And later it become, part of the curriculum for Stanford Design School, Carnegie Mellon, and many, many other universities. And then it goes into IBM and General Electric. And today, everybody have their own design thinking companies, designing great products. Okay. So we should look at the GIS visual science as a product. And the competition is to create a great product. Okay. We have a big idea, doesn't matter. You just have a big hate saying that, we want to design a great product for Faculty of Science through this competition, a great solution. So now we go back to our drawing board, apply the design thinking, and then we will try to approach the problem by putting the user first. Okay, if users are not benefiting, it's go back to a drawing board. Okay, understand what exactly they want. Whether the students are getting clean water to drink from the water coolers, whether the water cooler filter are serviced according to the requirement. You ask this question. How many water coolers per unit square kilometer, for example? All right. And how much water we should drink per day. So if we can multiply all these and get a kind of evidence, then the stories start to emerge. There is a culprit, there is a villain, and you try to find a solution to this problem. And your proposal probably will fix that issue. Okay. So design thinking gives you solution-based thinking. Whereas in the university, we are still talking about problem-based thinking. And we get fixated to the problem. So we think problem is great. Yes, some cases problems are great, provided it's really a great problem. But if the problem is negligence and our misunderstanding, mismanagement, we cannot be proud of the problem. We should attack the best solution. So design thinking will search for that solution out of many, many possible solutions. Okay. So you need to prioritize then what is the right solution. Okay. So the scientific way of thinking for very complex problems, I think, the linear problem-based thinking will not break the ice, will not crack the rock. Okay, so people have showed that this design thinking, at least it gives you a variety of solutions that you can try, improve iteratively, and hopefully one of them will be the best solution. So it's basically applying Darwinian solution to problem. Okay, the fittest solution to the problem, and that fittest solution will evolve the technology. Okay, so that is a very exciting thing which sadly we are not propagating in the classroom. So we hope the GIS visual science competition will help. Okay, so now you look at the way engineers solve problems. They solve by taking the parameter, setting the goal and the data, and then they plug in the parameter to solve. So they assume the model is capable of solving. All they need is parameter and data. You can't solve complex problem with engineering thinking, because complex problem doesn't have a model. Okay, doesn't have a model. Business thinking, you optimize. Always look at the profitable solution, scalability, customer satisfaction. Okay, so always optimization. So that is the business thinking. Scientific thinking, hypothesis, experiment, analysis. So basically you are reducing the problem, which is real and complex, into a toy model which is reduced. And then you try to solve it. It will not fit the real complex problem. So scientific way may not be suitable for this kind of highly complex issues that we are dealing. Finally, if you look at models that accommodate uncertainty, accommodate volatility, accommodate complexity, and accommodate ambiguity, which we call the VUCA problems, the design thinking seems to be the natural approach, because we actually accept. We say, okay, the problem is complex. We do not know everything about it, but that doesn't mean we cannot start working on a crude model. Okay, so yeah, scientific thinking, as you tell, that was a long time ago, but then slowly you can make, you can see how the atomic model have changed so much. Okay, but still, it's still considered, when it comes to nonlinearity, you have to give up. When it comes to nonlinearity, many of the predictive models fail. Okay, so design thinking is supposed to bring all the chaos from research to a slightly distilled concepts, and then clarity in design. Okay, so that's the idea. The research comes up with all kind of questions, all kind of questions, all kind of hypotheses, approaches, literature review say this and that, and then you bring together, you have to distill, you have to empathize the scenario and the situation, select the one that's going to work, and builds on that and iteratively improve. Okay, so the design thinking as 6 process. The first part is understanding the problem. So I assume now you guys have actually understood what is the problem that you want to address. Okay, so you should be at that stage now. You are just playing with GIS as a platform, but the problem is the center stage. Okay, the problem is the actor. So now your understanding, you must be willing to tell yourself, I have understood a bit, I may not understand fully, I'll come back and redefine the problem if necessary. Rather than you say problem defined, problem definition, problem statement, well stated. We don't have that kind of scenario here. We come back, okay? Design thinking allow you to come back. redefine the problem. Once you redefine problem, ideate. This is where the innovation takes place. Your creativity comes at ideate. Okay? So you experiment with ideas, 5 ideas, 10 ideas. You try to see the prototyping of the ideas without building much. You prototype the ideas, say, I put this, what I will get. So this is like you are exploring. It's like a sandbox. You are playing with models. Okay? Then maybe you want to test 1 or 2. If it works, you go into implementation in the field. If it doesn't, you come back to redefinition and talk to people, empathize more. Okay? So I won't go into the detail of every steps because you can find all these. You can find all these in the references that I highlighted, and you will get some of this material as well. But the point is, empathize means listen to people. Listen what the place needs. Listen what the student want in the space. Listen to what the environment is yearning for. Listen to the river that raw not because it is forceful, but it is obstructed. So it is not a raw, it's actually a cry. When the river is blocked, the consequence is overflooding. So don't blame the river. Blame the people who obstruct the flow. So this is how we start to empathize. Okay? And we observe, we talk, we interview, we get opinion, plus and minus, supporting and against, and then come back to the drawing board. Okay? Define. You get a better clarity after your engagement with your client or stakeholder. You get better clarity. Come back to your design space, think about it. What is important? What should be kept? What should be kept in view? What should be put immediate test? What should be kept for the second revision? Okay. So once you define, then you start to ideate, bringing any idea from anyone who can enrich your solution. Okay. So this is where you must think out of the box. You must tell yourself, I don't understand this problem. Therefore, I will innovate my solution. You don't go and search for the solution. And your solution is your innovation, your story. It can win. Okay? It can win. So think about that. Everybody has a chance to win because you have a unique story, not a template solution. Bring the people into the picture, highlight the issue, give your interpretation, create an idea to solve, talk to all kinds of people, come back to the drawing board, test it out, map it up on the GIS, and tell the story. Okay, prototype, then you build just to test whether it works, where it failed, so that you can go back to your build to learn and test to learn, build to think, test to learn. Okay, then you test so that you know whether your solution works for you and it works for your user or the benefactors. Okay, and implement, cycle over many times because your solution will be improved by others in the next round. So no need to worry that your solution is the best performance. If it's B, let it be. Okay, but you shouldn't think that that should be your ceiling. Okay, all right. So in design thinking, there will be divergent thinking because idea comes in all directions. Then you have a groaning period where you actually struggle with all kinds of ideas. You know, because too many ideas, you are confused. This is the time where you talk, brainstorm, and you visually design, sketch your idea, connect the idea. This is where the visual thinking comes in. And then put it on the wall, look from far, see how points connect. The one that does not connect or need not to be connected, don't force to connect. Try to find the simplest lines that connect most points. Not many lines that connects many points. Then the simplest, the most, the backbone line will be your story map, your storyline. Okay, the storyboard. So there could be many ways to tell the story, but you found one that has the simplest way to tell the story, and the visuals are very compelling and very convincing. Okay, so it's almost like going into the forest to find all kind of things. Finally, you decide what to pick. Then the idea converges. This is where you integrate, you prioritize, you select which one requires the immediate action, which one will be favorable to the user, and then you propose that as your part of the solution. You don't propose all the solutions. So when the user hear your solutions, they will hear some of the refined idea that has gone through so much confusion and distilled to become very clear idea. So you need to ask all the WH. You have to ask what is the problem? Then you have to ask who is involved in this problem, who's contributing to this problem, who's in charge of this problem, who will benefit, if we solve this problem. Okay, and then why it's important, why we need to address this issue. Okay, and then you identify where is the bottleneck of a problem, the pain points of the problem. It may not be everywhere, but if you go and touch the pain point, and that's where it's important to solve. So you don't focus on everywhere. You may want to focus on the area at the Faculty of Science where the problem is acute, and that's where you're going to address. So now you see, by asking all these questions, from the 5 possibilities, 10 possibilities, it reduced to a few. Okay, so you must have first options, otherwise you won't have the selections. Okay, so that's why we ask you to work in 4 to 6 people. So you have 6 core brain thinking on the problem. Okay, and when it starts, how it begins, and how this problem actually can be seen as opportunity rather than a nuisance. Okay, behind every crisis there's opportunity. Behind every problem there's opportunity to fix, to learn. Then you ask what we would like to know. So you ask the person, if this is the issue, what you want to know from the student, what you want to know, from the administrative people, what you want to know. They are different people, they will tell you different things, and all these informations are useful. Okay, and so on. All right, so you see these WH questions, what, who, why, where, when, how, will actually gives you all the sticker, the markup sticker that you want to put up on your wall to bring all the actor, the villain, the source, the plot, everything together for you to start writing stories. Okay, so I spent a lot of time on design thinking because underlying design thinking is the visual thinking. Okay, so if you treat this GIS visual science competition as a capstone project or value proposition, you will be seen as a different kind of student. Okay, so you will be seen as someone who actually can take up a problem and then you can craft another problem from the raw problem and then present a solution that works. And this is the attribute that people are looking for. Okay, so the Faculty of Science is planning to introduce capstone project as alternative to final year project. Okay, Final year project is a traditional problem solving, very, logical, model understood. All you have to do is just crank your muscle and your brain to solve. There's not much of a challenge that come as there's no clue how to solve. Okay, so capstone project allows you to take up bigger challenge in numbers in a group, and then you can be even evaluated by the agency or industrial client. So if you solve problem like these, the companies or agencies will straight away see you as the asset. You are the kind of people they want, rather than trying to prove your CGPAs, which is not in many ways aligned to the real world expectation of what you should know. Okay, so this is one of the objective of GIS competition. So the faculty is planning, supposed to run this year, but many people have no clue what is a capstone project. So the makerspace is actually proposing the GIS competition as one pilot example of what should be a capstone project. So we take up this GIS. Okay, so it is made for audience beyond classroom. Okay, with student aiming for service improvement and impact. Exactly, it's real process. It's no longer something cooked up in a model which is reduced and simplified. You are facing the real problem out there. So you become, boys to men, all right, through projects like this, or girls to women, okay? So this is the kind of maturity that we gain from solving problems like this. It can be done. Don't underestimate yourself. And you are expected to use tools that professionals also use, like GIS. Okay. So these are the books that you guys can go and check it out. Huh? These are available online. If I can get it online, you can get it online. Okay. I'm also using this book since I engage with this kind of shift in thinking. I've been reading a lot and realizing that, this should be brought into classroom. Okay. So this competition is one way of bringing that into the classroom. Okay. So this is visual thinking that you are seeing out there. Okay. The visual thinking. And you have visual doing also. This is the visual doing. And you have the visual storytelling. All these are visual storytelling based on infographic, using infographic to tell, to communicate. Okay, guys, so I think that's the end of part one. Don't worry, part two is short. So that is the end of part one. So now let me open up some Q&A session. If you want to take a toilet break or grab some drinks, go ahead. We will take a break now for 5 minutes. Anyone want to ask any queries or throw a scenario?